name is Dragan Milosevic. I work for Zanox, and I will present the results of the study where we compare SolrCloud and HBase. Actually, on the beginning of the year, we had a chance to spend a few months to compare different technologies that we can use for reporting, and for this conference, I thought it makes sense to compare SolrCloud with HBase, because we are all very familiar with SolrCloud, and we can use that fact to learn something about HBase and how those two technologies are similar. So this is the short agenda. Please notice that I'm going to try to give a few guidelines, actually 8 of them, because this talk is declared to be a tutorial. I will shortly introduce me and myself and my company. Then there is going to be one brief slide about what is OLAP. And we will dig into matter with SolrCloud, and there we will see how we should use SolrCloud together with doc values for aggregations. The second part of the presentation is going to be about HBase, and it's going to give a little more details about how HBase works and how you can build a powerful reporting with HBase. Finally, I'm going to compare those two technologies. I'm going to do performance comparison and give you the final 2 guidelines about which technology is more suitable regarding the response time. And hopefully we will have time for a short summary and questions. So this is the first slide where I have a bunch of text and a little advice for you. If you see the slide with a bunch of text, try reading only the highlighted words. I was here actually also a little bit lazy and keep reusing this slide because I like when I'm preparing the slides that I say, okay, I have the slide about me, done. I have a slide about my company, also done. What is missing here and what is important for this talk is that I spend, let's say, at least 8 years in building different reporting systems. I build personally, or I was involved in building maybe a dozen of different reporting systems by using not only the highlighted technologies here, but many other technologies. That means I'm more or less the guy that knows how to do reporting. Here is the slide about my company. I have to spend a couple of minutes because my company paid for this trip, and I'm so grateful. What about Zanox? Zanox is an affiliate marketing company that brings together publishers and advertisers. Publishers are the sites that have the useful content, and because of that have the visitors and want to monetize those visitors. And what publishers actually do, they send those visitors to advertisers. Advertisers are online shops that need visitors who are going to buy something. And Zanox is in between, that is bringing millions of publishers together with thousands of advertisers. And always when the particular user sends from the publisher to the advertiser, buy something, advertiser is going to pay the fees to my company and commission to the publisher. Because of that, it's performance-based. And very important component here is reporting. Reporting that is providing very accurate information to the publishers and to the advertisers, how they are performing. And because of that, my company is quite willing to invest some money and resources to check different technologies and always build state-of-the-art reporting systems. The very important, okay, we have a small technical problem. Let me quickly go to the, okay. Here's the next slide. We are digging into matter, and we are explaining what is OLAP, what is online analytical processing. And I created one figure that presents something. Presents actually that we are pre-computing data where we are grouping everything based on the year at one dimension, and in the second dimension we are grouping everything by advertiser. And I have a few measures like assist clicks, click count, and commission. Such a pre-aggregation is then very useful if you want in real time to respond to the question, for example, how many assist clicks has advertiser B in 2015? And presenting it this way, it looks quite simple. But in reality, on a time dimension, you don't have the years as a granularity. You have something like a day, or even more, you have hours, because you want to be able to support a lot of different time zones. That means on a time dimension, you are going to have hour as a granularity. Then when we are checking the advertiser dimension, for example, okay, irrespective to the fact that you have thousands of advertisers, those advertisers have so-called different ad medias. Those are the products that they sell. It means you can think about that the advertiser dimension is also a dimension with a high cardinality. And finally, when we are talking about measures, you can have hundreds of different measures. You can have the sales, open sales, rejected sales, leads, commissions, different types of clicks, and so on. That means you are going in a direction that even when you pre-aggregate everything, you have a big data. And because of that, it makes sense to compare different technologies and to see which one is suitable for a particular task. About SolrCloud, well, I didn't want to pay a commission to Mike Miller to the nice SolrCloud figure that he has. And I put it something that I made by myself, and it is definitely without copyright. But I assume that everybody is familiar with the SolrCloud and that I don't need to spend time in explaining. But I will repeat Yonik about the store fields. That store fields are not suitable for reporting. Store fields are optimized for retrieving the values of the small number of documents and should be used only for that. And on the bottom, I'm illustrating that in store fields, all the fields that belong to the same documents are actually stored together. Which means if you need to access to the particular field for many documents, you don't have the local access. And that makes the sort field not suitable for reporting. Or it's better to say it's not so easy to use them for reporting. In 2013 at the Lucene Revolution conference, I gave a talk, and at that time we didn't have doc values, and in spite of that, it was possible to build reporting with Lucene without doc values. We used a little bit of machine learning and frequent set mining to put the frequently accessed fields together in one bigger field, and additionally we analyzed the filters and the groupers, how they are used, in order to put the documents in the right order so that you have that locality that is necessary for maximizing the benefits of the file system cache. But my tip too is it's hard, and don't do that because you have doc values. And what are the doc values? On the previous talk, Yonik explained very well that's a column storage that you have in Lucene, and you have that also in SolrCloud. And here on this slide, I was presenting a few more details that point out that it's not, you have the list of numbers, for example, on a particular field, like here, sale count, sale number. The doc values behind the scene do much more. They will compress those numbers very efficiently. They will do, for example, something like delta coding, where you are storing the difference between the subsequent numbers, or they can do something like frame of reference, where you are going to find the minimal number and store the difference between that reference and all other numbers. or if you have exceptions, for example, very big number, they can do a patched frame of reference and much more. And everything is happening behind the scene. That means doc values are really ensuring that you are capable of very performantly accessing the values of the documents that you select. So my guideline is, if you are doing reporting, use doc values, and even though doc values are seen, okay, you are storing something, and somebody can say, okay, then I have to say store true. Actually, that store true is only for the store files. That means it has nothing to do with the doc values. And you have to say that doc values are true, that he's going to create doc value files for you, and if you want to search, then you have to index, but you have to say that they are stored only if you want to get them when you are retrieving the hits. And intentionally, I put some Java code here to show how easy it is to write a search component that uses the doc values. It's only a couple of lines. That means you will get atomic reader, leaf reader, very easily, and he is offering you the access to the doc values if the doc values are, say, available for a particular field. And when you have the doc values, you have the method to get a particular value. And this small code is simply summing everything. It means in reality, when you are doing aggregation, you will have a little bit of grouping, you will have some kind of input argument that says on which field you want to group and so on, but more or less these few lines are the lines that are doing magic. And here probably everybody is familiar with. When I have the search component, I have to build a jar that I am putting on a class path. And I can then declare the search component with a given name and use that search component in a request handler. And that's more or less everything when we are talking about how I can use doc values in SolrCloud and how I'm writing the search component that is performantly accessing those doc values and doing everything on a server side. Now I will start with HBase, and I have again one boring slide with a lot of text. I intentionally do that you can see for the SolrCloud you have a nice clouds, sunny clouds. Here you have the boring text, but let's see what I highlighted. And if nobody knows what is HBase, you can see here, I have database, distributed database, I have Hadoop database, big table, something similar as a big table. What else I have? I have column family oriented storage or multidimensional map. And Java, open source, more or less, I will say you don't need to read the text that is not highlighted. And because I assume that you are not so familiar with HBase, my intention here will be having the few slides that are summarizing the HBase architecture, and I'm going always to point out how that works in SolrCloud. Means in HBase you will have the table. The table has, in this case, 3 regions, and synonym for the table in SolrCloud is a collection, and synonym to the region are shards. What is here different is that I have column families and I have row keys. About the column families, the columns that I have, that my records have, those attributes that I'm putting in the Lucene documents are here columns, and those columns are grouped in column families. And what I can also notice is that column family has one or maybe couple of files where I'm storing the values. In optimal case, I will have only one file, one so-called H file after the major compaction is run. That means and those H files, you can think about them as something like a segment. And what I have here on the right-hand side of the slide is that those files are saved in the HDFS on different machines that are on different racks. It means that's the way how HBase takes care that you're not losing the data. A particular H file where you have the data is going to be replicated, and typically I will have 3 copies, and 2 copies are going to be typically on the one rack, and the 3rd copy is going to be on a different rack, so that even if the whole rack is gone, you are not still losing the data. What about the row keys? Well, row keys are used for sorting the records, and they are defining the order in which the records are saved in those H files, in those files that are replicated in HDFS. That further means I have very carefully to build my row keys that are going to reflect that the data that I need are afterwards locally stored, that I have that locality. It means here we are again insisting on the locality that you have with doc values and in SolrCloud. In this case, for example, I showed 2 row keys that are the composite row keys, where I am having in the first component so-called identifier, then comes, for example, advertiser ID, date, and so on, and that identifier says more or less how you should interpret the further components. And from those different components, we are building the row key by using the Orderly as an open source library. Orderly is known to be very good in building the byte array that HBase needs as a row key and preserving the natural ordering of that is defined by each single component. In this particular case, I will have all A identifiers first, then as a second sorting criteria, it's going to be advertiser ID and further on. Why is that important? I will show in 2 or 3 slides where I'm going to give few guidelines for reporting with HBase. What about different column families? Actually, you have a bunch of columns. You have assist clicks, conversion rates, click number, and so on. In our case, we have more than 100 different columns. And the challenge that you have is deciding in which column families you should save those columns. Because you have a couple of column families, and you have to decide what should be in which column family. Those challenges I summarized here, and again, what I highlighted is that the main goal is to minimize the number of column families that you have to use for a particular query. That means when you need more column families, that immediately means you have to access more H files, and that means you have more file accesses, and that is going to make that your response time is going to grow. It means the primary objective is to minimize the number of column families that you need for queries that you have to support. And in order to achieve that, I said here, you can duplicate the data. Duplicate the data means important columns you will save in multiple column families. But at the end, it's really an NP-hard problem, optimization problem. And how to solve that? Together with a few guys from Shanghai, we did a research. We spent almost a whole year checking how important is to put the columns in the right column families, and that's a quite novel research. And we published a few papers, and one paper is published here in San Francisco in California at one IEEE Big Data Services conference a couple of months ago. And what we have here, I haven't highlighted anything. I'm even not sure if it is copyright okay with the guys. Hopefully nobody is coming to me. But you can notice here at the end of the abstract that we said something 72%. That means what we did, we apply evolution algorithm, design evolution algorithm for finding the optimal structure of column families and created few possible column family structures. And then we compare, and then we figure out that we are optimizing the response time up to 72%. One naive column family was semantical one. For example, I am putting all sales-related measures in one column family. I am putting all clicks-related measures or columns in another column family, and so on. And it sounds reasonable. But when you check the queries, which attributes are needed for a particular queries, you are figuring out it's actually not so that the users are asking only for sales or only for clicks. They're asking, for example, either for all open sales together with valid clicks or something like that. And you have those queries, and you want to build better column families. And if you are building the better column families in this paper and this research work, by the way, Fang Zhou was a student in Berlin, and that was his master thesis. We show that you can speed up the things up to 72%. And finally, I said, okay, I explained enough about HBase. I am going to start to give the first guidelines when you use HBase. And the very important guideline I rate it as the most important here is to use the endpoint coprocessors. What are endpoint coprocessors? A lot of text here. If you know what are search components in SolrCloud, those are endpoint coprocessors in HBase. That means they offer you the ability to inject your custom code on a server side and to execute on a server side. Don't be scared, I won't give the code examples. They are not so trivial, a few lines like in SolrCloud. You will need a little more lines, but anyway, it's not so difficult to write your own endpoint coprocessor. And what it does here, for example, I show the example that picture on the left-hand side. You are selecting the relevant keys that you have. Those relevant keys are in two regions. HBase is offering you the high-level interface that it is selecting for you the regions that have the relevant keys, and it's going to execute your endpoint coprocessor code only on those regions remotely and send you the results what endpoint coprocessor produced on the client. That means, very important guideline, your reporting with HBase won't work if you are retrieving the records on a client side and aggregating there, because the network traffic and the time that you need to transfer the record is going to dominate, and you won't have the system that performs well. Use coprocessors. What is the next guideline? Next guideline is the row key design. And that's something that is well known in HBase. For all different applications, they said it's important how you're designing your row keys, because those row keys are used for sorting the records, as I mentioned, how they are saved, and you want that the records that you need are locally saved next to each other. One extra point here is if you have the bad design of the row keys, then you will have maybe the hotspots by writes. That means in this design, I don't have actually probably the hotspot when I write the records. Hotspot means when you write the records, all the records attack and then hit the same region. And then that region is going to be a bottleneck, the region server. You want to spread the writes across the whole cluster. And in this way, you assume that different advertisers are going to have clicks or views or sales that you store, and you're going to distribute them very well across different servers. What I have here as a red mark, you should use as a filter something that is on the beginning of your row key, because then you have locality. In this example, advertiser ID is very good to be used as a filter, because you will set identifier. I have identifier that's advertiser. Then in your query you're giving advertiser ID, nice, and then you're giving the time range. And then all the selected records that are relevant for the query are going to be saved next to each other, and you will have locality and you will have a nice response time. But if you pick as a filter something that is not on the beginning of your row key, then you will have the records that are scattered in the whole H file. You don't have locality and you will have the poor response time. Something that is here new is the last guideline, and that guideline is what I mentioned with the column families. That's something that is quite new. And we spend a lot of time in trying to collect the state of the art, especially was hard when publishing the paper and reviewers are complaining, okay, compare that with what already exists. And we really spend months in researching what is already there. And nobody is tackling the problem, how you are building the column families, which column goes to which column family. And in the results that I mentioned, it's very critical that when the query comes, you will have everything that you need in as few column families as possible, because then you will use, in this example, I'm finding everything what I need in a single column family on the left side. On the right side, everything is scattered around 3 column families, and I will have to access to much more files. Not so good. Here, I intentionally haven't said that it's a guideline number 9, because I didn't want to give more guidelines for HBase than for Solr. But more or less, the point here is that if something arrives, if somebody sends the query that is not expected, that can be very expensive. But I'm pointing out, usually you are not getting the queries that are surprised queries. In our case, we have the UI, the front end, and there you have predefined reports, a dozen of them, and that's it. That means the user is practically not able to send you the query that you are not well prepared on. Okay, I will have 10 more minutes and enough time to shortly summarize the response time measurements that we did. And here is the guideline number 7. We compared how fast is SolrCloud with HBase when you have to aggregate really a lot of numbers. Typical queries are not aggregating 10 million numbers, but let's say not more than 100,000 of them, because you already have pre-aggregated data stored on an hour basis, not so many dimensions and so on. But in order to see how everything behaves, we created the cases where you have to aggregate up to 10 million numbers, and we saw that doc values are performing a little better. Maybe because of that extra compression that doc value have. By the way, in the experiments that we performed, we took care that the files, that most probably everything was in a file system cache for SolrCloud, or for HBase, that everything that you need is in a block cache. That means that's something that you cannot be faster than this. And here we see that the time difference between those two technologies is minimal because of that guideline number 7. If you don't aggregate over too many column attributes, or if your attributes are not huge, pick the technology that you want. It's, I cannot say pick SolrCloud or HBase, pick one that you already have in-house, the one that you are comfortable with. You don't need to invest time in learning HBase. But if you have to aggregate over many different columns, and if in this graph all the columns are 10 million columns, that means huge. Maybe that's not so realistic, but in our case, there are big clients that we have also to optimize. In this case, because and this measurement is done that in HBase you have the column family that is carefully built. That means I'm already minimizing the number of column families that are needed. To be honest, everything is in a single column family, and only the thing that you need are in that column family. And because in HBase you will have the single index where you search, we see that HBase wins. It means if you need to aggregate over many big attributes, I will say that HBase is a better fit. Let's make a short summary. Those are the guidelines that I provided. It means the first guideline was don't use the stored fields for reporting. Second guideline, seriously, don't use stored fields for reporting. And if you're not convinced, check my video from Lucene Revolution 2013 and see how nightmare was there to use machine learning and to figure out how to build your index. The third guideline is about doc values. Doc values are really, really great. I was so happy and thrilled when I saw that they were finally integrated in a Solr and SolrCloud, and that you do a simple setting like doc values equal true, and that you have your doc values that you can use. The tip 4, 5, and 6 are guidelines for HBase. Endpoint coprocessors are something that is must if you do reporting with HBase. Similar as search component in SolrCloud, endpoint coprocessor is for HBase. You will have to carefully design the row keys, but that's nothing new. All the books about HBase are saying row key design is very important. What is new here is the guideline that you have to carefully design the column families. Only in that case, you are getting that the HBase wins against SolrCloud if you have aggregations over multiple columns. Finally, the guideline 7 was pick any technology in most of the cases. And those most of the cases if you don't aggregate over too many huge attributes. And probably you won't need to aggregate over too many attributes at all, because you have the filters, and filters is already selecting what Yonik was showing. Probably he's aggregating over 10,000 or 50,000 values, not more. Before reporting, maybe have a necessity to aggregate over 1 million and so on, but still, if you don't have too many such attributes, any technology is a good fit. And the last tip was use HBase if you have such huge attributes. Okay?
One question.
Yes?
So basically, for the doc value, is all the doc value fails to go from the aggregate managed to the memory. So basically, if you have several columns, that means just several big arrays in the memory, then it will get from array. So basically, get from the memory. Now, the question is why HBase will faster than the doc value for multiple?
Okay, the question is about why HBase is faster if you have to aggregate over several attributes. Because doc values are, again, most probably all in memory, in file system cache. The point is that for doc values you have to, we explained that, the results, because doc values you have to search separately in each file to select what you need. And in HBase, you have one index that is immediately selecting all the values that you need to aggregate. That means the searching part is something that for HBase is done only once for all the columns. And in SolrCloud with doc values, you are separately searching in every file because each column is a separate doc value file. And but that's separate for each column. That means you have separate arrays for each column, and if you aggregate over dozens of columns, you have separately to select the parts of that array. And that array, it is most probably in memory. It is in a file that is hopefully in file system cache. In our experiment, we warmed the cache, and we already used, and we ensure that it is in a memory. But the important point to remember is you are searching separately for each file, and in HBase, you search only once. Yeah?
Two questions. So just to clarify, the columns that you are searching in HBase is all in the
It is not necessarily in raw key you have something that you are using as a filter, but the values like sale count, commissions, fees, and so on are columns. And those columns are put in the right column families based on the queries that you got in the past.
So my second question is, do you use the Bloom filter at the row key level or at the column level?
Very good question. Question is about do we use the Bloom filter? I wanted to have that on the presentation to point out that the same thing that you have with blooming in SolrCloud, where you can write your own codec that is not checking the segments that are potentially, that are without the data that you need. The same blooming you can activate also on the HBase, that you are not checking the H files that are without relevant data. Those experiments were without blooming, but blooming here, because the records that we have are very small, blooming is very expensive because the Bloom filter is going to be big. And because of that, I leave it that to make it fit in 40 minutes. Yes?
Yeah, you said like across columns, if I'm doing an aggregation, HBase would be more appropriate. So you have any kind of a use case that you can give us, like where you have to do aggregation across columns? Or
Okay, the question was, do we have a use case where we need to aggregate over a lot of columns? Well, the typical queries that the users are sending are, they're interested in the number of sales, then they're interested in the number of rejected sales, open sales. Then we create different measures based on the clicks, like number of clicks, number of invalid clicks. Then we are building some kind of a chains of clicks that led to a particular lead or sale, and then in those click chains you can count the clicks that assisted to the sale and so on. And then you will have the attributes that are fees and commissions and so on. That means typically the query has at least dozens of attributes that you aggregate. On maybe short, only one question and the time is over.
So basically, there was a big drawback in HBase was that the queries are static. You can't actually give any generic queries. Where Solr will win hands down, right? Because a customer changes the query, you will not be able to do anything about it.
Okay. The observation, very good observation, was that in HBase you have this more or less static predefined queries, and in SolrCloud you can support any query on the fly, and that's very good advantage, and that can be also the guideline. That means if you have unexpected queries, use SolrCloud. But usually you have the queries that you know in advance, and in such case, HBase is a very good fit. Great. Thank you very much. Maybe we can continue outside as they requested. Thank you.